In this video we will install a Nomad+Consul cluster onto the Google Cloud Platform, and we will see how we can use it to autoscale an application. But first let's install some prerequisites. The first requirement is the Google Cloud CLI that you need to install onto your local system. I'm using Windows here, so I need to click over here to run the installer. This will take a long time, so I won't do it now, but I already did it before. And after that you will find the Google Cloud SDK shell inside your start menu. For different operating systems there is a different procedure to install the Google Cloud shell. The second thing we need is HashiCorp Packer. We will use that to build our image. You can find it over here. Again, because I'm on Windows, I need to download it over here. And then the same goes for Terraform. You can simply download the zip file, and then we're gonna extract that zip onto a folder. Once the files are downloaded, we can extract them to a folder. So let's create one over here and call it HashiCorp. The HashiCorp products consist of a single binary, so it's easy to install them. After we've done this, I'm gonna add this to the Windows path, so we can use it from the command line. So let's go over here and add a new entry. Let's move it all the way up, and now if we run a command line prompt, we can execute Packer from anywhere, and also Terraform. So that's done. And finally, let's also install JMeter if you haven't done so. You can find the zip file over here, and we can extract it to a folder. For example, in a folder called Apache. Once you've extracted JMeter, you can run it by running the JMeter .cmd or .sh. Okay, once we're all set up, we can go to my repository, and we're gonna clone this repository. I assume you've already installed Git on your system. So I'm gonna clone this repository over here. When you're using Windows, make sure that you put the settings for Git so that you don't convert the line feeds to carriage returns, because in that case the image will be messed up. So if you look at my settings, you can see that I'm using Autoscaling with input, so it retains the input from the repository. So if the repository consists of only line feeds, then it will stay that way. So if you now open files over here, you can see that they have line feeds and no carriage returns. So that's just a small thing to watch out for if you work on Windows. Before we can build our image, we need to create a project on Google Cloud. So I'm going to this URL, and I need to log in to my Google Cloud account. And now I can create a new project. So let's click new project and call it demo. After you've created your project, you will find the project ID over here. I'm going to copy it. Then I'm going to navigate to the place where I cloned my repository. I'm going to go to examples, Nomad+Consul image, and I'm going to change this file. Over here you will find the project ID. You need to enter the project ID that you just created and then save it. And now before we can build the image, we also need to enable the compute engine. So if you go over here, you need to enable it. Before you can enable it, you need to link a billing account. Therefore you need to have a billing account, or you can register for free, and you get like I think $300 worth of credits from Google Cloud, but you need a credit card for that. But that way you can use it as without paying anything. So now the Google Cloud API is enabled, and I can go to the Google Cloud shell and log in. And once I'm logged in, I will go to the place where I have my repository. And then from here I can run packer build. And it will create the image for us on Google Cloud platform. Okay, so now it's done. We've just created an Ubuntu 22 image that contains both Nomad and Consul, and it can be used as a server node or as a client node. This is just for demonstration purposes. If you run in a production-like environment, you don't want to use this Ubuntu image, but you probably want to use Caravan or something to set up a cluster for you. But this is fully working, and we can see how Nomad and Consul are installed inside this image, and we can also change it and update it if we want to. You can now find the image also over here should be here. You can see here our image and the size it takes. Alright, so the next step is to use this image to create our cluster, and we will use Terraform for that. So we'll go back to this project, and over here you'll find the Terraform variables that you can change. Over here again is the project name, so we need to change that to the name of our project. And over here you can find the name of the image that we're going to use to create the server, and here the one for the client. So we're going to use both the same images. We're going to use this image, so I'll copy this and put it over here and also over here. So this is gonna create a cluster containing of one server and 2 clients. In a normal production environment you will use 3 or 5. You will use an odd number of servers because of the consensus protocol that requires that you have a majority of votes. So if you would use 2 instances instead of 3, then there's really no decent failover. So it's recommended to use 3 or 5. If you use any more servers, it's also becoming slower to reach consensus. But for this demonstration we will use only 1 server. We will use 2 clients. The clients are the workers that our applications will be deployed on, and the servers are the ones that will divide the workload. So now let's go back to Google Cloud and the Google Cloud Shell, and let's go to the main folder over here, where you can find the variables. So over here we can say Terraform init, it seems like I made a mistake somewhere. Oh yeah, I forgot the closing double quote over there. So let's try again. After we've done a Terraform init, we can do a Terraform plan. So this will show us what it will do. It will install 2 clients, as I said, in this region. So if that looks good to you, you can say Terraform apply, and now we can only say yes, and the cluster will be created for us. Terraform uses the HashiCorp configuration language, currently on version 2, and that's a very easy language to use. It has some advantages over YAML. It's easy to read, for example, and okay, so once this is done, we can go back to the Google Cloud Console, and over here we can see the VM instances that have been created. one server and two clients, we can copy the external IP address of the server, and we can actually go to that server and go to port 4646, where you will find the Nomad UI. I think it's still initializing. It should be there. And on this port will be the console UI. You can see this one's already working. We can see the services that have been deployed. We can see that the Nomad service is still unhealthy. That's probably because it's still initializing. Nothing to worry about. Now it's done, and now this one should also be reachable. And over here we can see also the setup of our cluster. We can see that there's only one client active at the moment, but I think it won't be long until we can see the second client in here as well. So now we can create some jobs on this cluster, but first we'll create a small demonstration application. For a demonstration application, I'm gonna go to start.spring.io to create a small Spring Boot application. We're gonna use Java, we're gonna use Maven, and I'm gonna create a demonstration application called Pi Calculator. This is going to calculate the value of pi, and it can be used for this demonstration because it will generate some load. Let's just use Java 19. We're going to add some dependencies. I'm going to add the web dependency because I'm going to create an API, and I'm also going to add the actuator dependency. This will give us a health endpoint. So that's it, and after this is done we can press generate, and we can extract the generated application. I'm gonna go to this demos folder again, and over here I'm gonna create my Pi Calculator application. I'm going to open this project that I just created with IntelliJ, but you can use any editor that you prefer. So let's just open this as a project. We're going to create a package over here. Let's call it controller, and in here we're going to create a Pi controller. It will be a REST controller with one method. Called getPi. It will be get mapping, and it will map to this path, and we will also have a path variable called iterations. Will return a double value. This contains the value of pi. So now we will calculate pi. Let's let's create a variable. Let's initialize it to 0. And let's also create a second variable called term. Now we can create a simple for loop. And in here we can okay, this will calculate the value of pi, because pi is an infinite series of 1 minus 1/3 plus 1/5 minus 1/7 plus 1/9 and so on. So that's what we're calculating here, and then at the end we're gonna return this value, and we need to multiply it by 4 for the 4 quadrants of a circle, and this will give you the value of pi. The nice thing about this function is that we can input the number of iterations, and the more iterations we will use, the more accurate the value will get, but also the more resources it will take to calculate the value. So that's perfect for using as for a load test. So let's save this and run it. And see if it works. So it's running on port 8080. So let's go there. Localhost 8080, and then on the path pi we can specify the number of iterations, and you can see that it will give us a value. If you give it a bit more iterations, you can see that it's getting more accurate to the real number of pi. So now that we see that it's working, we can go to the folder where we've created the project, and we can use the Spring Boot plugin to build our Docker image. Make sure that you have Docker daemon running, so Docker desktop for Windows, or just a Docker daemon for any other operating system. And then we can just use this plugin to build the Docker image for us. We don't need to create a Docker file. Okay, once that's done, we can see that we have our image now. It's this one called Pi Calculator. We're gonna create a tag for it. And now we can just So now I'm just logging into my Docker Hub account, and I'm pushing the image that we just created, so that later on from Nomad we can pull it again from the public Docker Hub. We can also test it if you like. Okay, so now it's running from Docker, and you can see that we can still use it. Why do we want to scale our application? If you run your application locally like so, and you go to the URL and you start a long-running request like this, you can at the meantime start another request, and you see that it will be served while this request is still running. So we can actually run 200 requests parallel by the default configuration because of the Tomcat number of threads used by Spring Boot. But this second request will just take slightly longer because this one was still running. So now it's of course not that much difference, but in a real production situation where you have a lot of load, some customers will notice when there is a heavy load on the system, they will be served longer. It will take more time. So we want to prevent that, and we want to optimize the service experience for them. So and to do that with as little cost as possible, we want to scale the application and create multiple instances when it's necessary, and scale down again when it's not so busy. So that way we have a good trade-off between efficiency and costs. So there's two ways you can scale. You can either scale horizontally the Nomad cluster itself, the two clients that we have now. We could scale that up to 100 or even 1,000 clients, but we chosen to keep that stable. We will scale the application for now, so we'll just create more instances of the application, and they will be spread over the different clients that we have, over the two nodes that we have, the two clients. So that's how we are scaling now. So now that we've created our application, it's time to deploy it onto the cluster together with some other services. So let's first go to the Terraform Google Nomad repository. Over here you will find a few job definitions. Let's open the Autoscaler job. This is also a HashiCorp configuration language, and it is a specification for installing the HashiCorp Nomad Autoscaler Docker container. So we can copy the content of this document, and we can start a new job, put this in as a definition, and you see that we use these data centers. If we check our cluster, we can see that it's now deployed on Europe West B and D. So we can change this into B and D, and this stuff we can all leave as it is. Now we can press plan and run. You see there the same structure as the Terraform, and now we got the Autoscaler service running, and we will also start the Prometheus service. So I'm going to copy that definition as well and paste it in here. So this is the Prometheus, this version from the Docker Hub, and we will deploy it also onto B and D. And Grafana we will leave for now, but we will go to the PyCalculator project. I've created a folder over here, and I've added a few job definitions in here. First of all, we have the HA proxy. We will use that because we have multiple instances of Nomad running. We will use a proxy, so we can access it via one address, and it will automatically route us to one of the available instances. So again, I changed the data center over here, and if you look at the definition of this job, you will see that it runs on a static port 8080. It's normally not advised to specify static ports because you want to let the Nomad assign the ports for you as much as possible. But for things like load balancers, it's handy to have a static ports so you know where to find them. And so we can execute this job definition as well. Another thing I want to mention is here the this specification is pointing to the SRV record of the DNS, and over here you can find the application name. So it's going to look for DNS records containing this name, and then it will use them for the load balancing. So all the instances that have this PyCalculator will be found, and we will use the round robin schema to select one of the instances to send the requests to, so they can handle the requests. So that's the specification of the our application on the load balancer. Alright, so let's also create this job. You can see the other jobs are already running. So, and finally the PyCalculator itself. You can see that I've specified it to scale from 1 to maximum of 8 instances. These instances can be deployed on either of the nodes, the client nodes that we have. We have 2 nodes. Yeah, there is some specification of the policy to use when scaling. You can see over here a query that's been used. This is actually a Prometheus query that we will feed into Prometheus, and to ask about how much CPU is available, and if it's the CPU usage is higher than 25%, then we will scale the application up. This is the port of the application itself, but it's not the port that it will be listening to in the cluster. And this is the actuator health endpoint that has automatically been created for us by Spring Boot. And this is the image that we're using. We pushed it to my local Docker Hub account, and we can pull it from within Google Cloud like so. So let's just see if it works. I'm gonna run this job as well, and as soon as it's running, we should be able to access our application on the internet. So let's first find out where our application is now running. As you can see, it's still unhealthy, so it's probably still initializing. Our job remains pending, so there is something wrong. It's not starting. So let's find out what's going on. Let's first click on it and then view the logs over here. We can see that it has not enough memory. We want to have at least 400 megabytes, but we didn't allocate that much. So we're gonna fix that. So I'm gonna go to the job definition over here, and let's make this memory 512. And now we can insert the job definition again. And it will just replace the deployment that it tried to do. And hopefully now, yes, now it's running. So you can see it's becoming green. So now we have everything running. And we can also find it in console. This is the servers. You can see here the IP address where it's running at, and you can also see the port that has been assigned. You see that it's not 8080, but it's a different port that has been assigned by Nomad. So now that we know that 05 is the internal address, we can see that is this server where it has been deployed. And actually, if you look at the clients, you can see that all 4 our services have been deployed on this very same server. That may seem a little bit weird, because you would think that it would spread the load of by spreading the applications, but actually this is different type of services that all cooperate together, and therefore it's better to put them on one server for less latency, as long as there is enough memory, of course, on that server. So that's what Nomad did for us. There's no need to customize that scheduling ourselves. Now that our application is up and running, we should be able to access it via the load balancer. So we can use the external address of one of the clients. Let's say this one. And we should now be able to access our application like this. But you will see that it's not working yet. This 8080 address has not been added to the firewall configuration. The 4646 address has been added by a firewall configuration in Terraform. That's in the repository that we have run earlier. But this 8080 port has not been opened yet. So we can go to the firewall settings, over here, and now we can create a new firewall rule. I'm calling it allow Nomad services. It's an ingress rule. We can use it on all the instances in the network, and for any IP address we will allow port 8080. And by the way, while we're at it, let's also add the port for Prometheus, because Prometheus has also been assigned a dynamic port, and it's this one. So I'm copying this, and we'll also add that to the firewall rules. I think we're done, and let's hit create and see if it's working now. So yeah, if I now press it again, you can see that I can access the application, and if we go to the Prometheus port, we get the Prometheus UI. So now while we're at this place, let's also go back to our Pi calculator job definition, and you can see the query that we're using for scaling. We can execute that in our Prometheus UI, and you can see the result over here. If we show it as a graph, you can see that this query is the one we're using, and this is the percentage of the CPU that's been allocated. You can see that it's very low at the moment, so we will need a load test to demonstrate that we are actually scaling the application, and that we will run multiple instances. You will now see that there will only be one instance over here. So let's create a load test to make the auto-scaling work. Open JMeter. Now I will create a load test. Let's create a thread group. Let's use 10 threads and a ramp up period of 30 seconds. We will let it run forever. We will stop it manually, and we will add a sampler for the HTTP requests. We're going to use this IP address, and we will use the port of the load balancer, and we will make a call to the path pi, and we will use a variable here as well, the number of iterations, and for that we will create a random value. Let's use a value between 100 and 200,000. And finally we will add a listener, the result tree. So now let's run it and see if it works. Yes, it's running. Let's stop it for now. So you can see that it's green. The request has been served, and we can see the response over here. All different approximations of pi depending on the input value, the number of iterations. So now that we're ready, we can go to Prometheus, and we can observe what's happening with the load once we start the test. You can see over here that we already saw some loads during the small time we run the test, but now we'll run it again, and we'll follow what happened with it. So let's run it again, and you can see that the load is becoming high. It's over 60%. As you remember, the query says above 25% you should scale up. So now the server is already scaling up, and you can see that because this load is dropping, and this usually means that there has been an extra instance created. So then the load drops a bit, but because we use a ramp up, the load still becomes more and more, so then we need another instance and so on. So finally it will stabilize around a certain value of the load, and we can now see how many instances have been created. If you refresh this, you can see that there's 5 instances running. I think one of the instances is still initializing, so this is showing up as red, but now you can see that it's green again. And over here in the Nomad UI you can also see that we have 8 allocations. If you remember, we have on this server we have the Prometheus, the HA proxy, and the Autoscaler job running, and also we had 1 instance of the Pi application, but now we have 2 instances of the Pi application running over here and 3 over here. So this second node is finally being used now. Yeah, so you can see that yeah, we got a very stable load on the system, a little bit above the 25% that we specified. But we can do that with 5 clients. We set to use a maximum of 8 instances, but 5 is enough for this situation. So you can also go over here to the jobs, to the Autoscaler job, and then to the group, and from the group you can go to the task, and finally you will find the log here. And here it also tells you that it's scaling, and it's scaling now between 3 and 4 and 5, depending on the load at that moment. So if we now stop the test again, you can see that the load will drop down to almost 0, and the instances will slowly die out until there's only 1 left. So that concludes our demonstration. Thanks for watching.